guys, I hope you are fine. Me too, I'm fine. So guys, let's attempt this question and see what we shall get. First, I read the question. Solve the differential equation. And so guys, this is a homogeneous equation whereby we use substitution. We substitute y over x with v. That is y all over x we are supposed to substitute with v. And so guys, after that, we differentiate v with respect to x. This one we get dy all over dx gives us v plus x dv dx. So guys, let's dive into this question. So guys, we come and now divide here by x squared. We divide the numerator and also the denominator. Only for this side, not for this side. When we do that, guys, we are not changing anything. The value will still remain the same. It's only that we are changing, we want to change the variable. So guys, we are going to have dy dx. We now come this side and now divide. We divide here by 1 over x squared, and here we divide the same 1 over x squared. So when we divide the numerator by x squared, we get 1. And that one we decide when we find that, for example, here it's squared, and here is squared, and here is squared. That's why we have chosen to divide by x squared. So this one will give us 1. And then here, guys, we are going to have y squared all over x squared. And this one is now divided by the denominator, which is 2. And this one we shall have now 2 around, because if you divide x squared by x squared, you get 2. So finally, guys, we come here and now replace our y over x, which is now v, and also replace dy dx, which is now this formula here. And so we shall have, here we shall have v plus x dv dx, and this other side we shall have 1 plus, this one we replace with v, so it will be v squared all over 2. Now guys, from there we can take our v this other side, so that maybe I can even cancel it and now put it this other side, so that we have minus v, because here it was positive, all over 1. So guys, we come and now do this sum, whereby now we, because this one is in the partial fraction form, we can now come and combine them, so that we shall have our LCM is 2. Then 2 divided by 2, we shall get 1 plus v squared. Coming to this one, 2 divided by 1, we shall get 2. So this is going to be minus 2v. So this one is equals to x dv dx, like that. So guys, from there now we come and we can actually do this, guys. We can transfer now these 2 on this other side, so that now we are going to have 2x dv dx. This one now will give us, we can write it in terms of v squared minus 2v plus 1, like that. so that now guys we can write it in factor form. So when we write it in factor form, guys, we are going to have something like this. We are going to have v minus 1 again v minus 1, which now translates to v minus 1 squared, like that. Try to do this and see whether you are going to get that solution, guys. This is v minus 1 multiplied by v minus 1 gives us that. So here we have 2x dv dx. Now at that point, guys, we can now be able to separate variables. Remember, at first we couldn't be able to separate these variables. That is, putting x on one side and y on another side, together with the dy and dx to the side, whereby if y we put on this side we put dy, if x we put this side we put dx. If we try to do that, it is not possible, guys. And that's why now we come and substitute. So that finally here we are able now to do exactly that. And this is now what we are going to do. We are going to put our dx this side, and then we put 2x here. This dx comes here, and then 2x comes down here. Then for v minus 1 squared, we bring it this side, so that we have dv there, all over v squared, v minus 1 squared, like that. Guys, from there now we come and integrate. We integrate this side, we also integrate this side. And as you can see now all the sides have their respective variable. This side we don't see x, and this side we do not see v. So for this side, we can start with this side, guys, and this is how we can do it better if we write it like this. Integral of v minus 1 now raised to negative 2. I have brought it up. Instead of it being down, I brought it up. And by the law of indices, that's how it's supposed to be. And then dv. This one now equals to integral of dx all over 2x. So guys, on this side, it's easy because it's going to be natural log of x, and then here we have a half, then plus c. And as I said, c we can also put it in terms of natural log of c. And the reason why we do that is because if we say natural log, we talk of c, and then we come and put now natural log of c, maybe it will give us d, but d is still a constant. So instead of changing that, I'll still write natural log of c, which is still okay. And this other side, if we integrate, we are going to have v, it's going to be v minus 1, that is minus 2 plus 1, we get here minus 1, like that. And then down here, guys, we are going to have minus, not down here, but we are going to have a minus here. Because we are going to have minus 1 here down, of course, this represents a minus on this side. So guys, we are now going to have something like this. We're going to have minus 1 all over v minus 1. Now with that is now raised to 1. This now gives us 1 over 2 natural log of x plus natural log of c, like that. We can combine these ones. For this side, we can combine them and write it like this. I have Instead of writing a half, we write natural log half, we bring it here. So we shall have, if we combine them, natural log of c x raised to a half, like that. And this other side we shall have this term, which is negative 1 all over v minus 1. So guys, we now come and replace our figure, that is y all over x equals to v. And so guys, that's what we are now going to do. So guys, we now come and remove this minus. So how can we remove this minus? Guys, let me give an example. Let's say you have something like negative 4, negative, and then into bracket 4 minus 5, like that. We know the solution for this one is supposed to be 4 minus 5, which is negative 1, and then you multiply by 1. This one gives us a solution of 1. So if I want to remove this negative, guys, I can come and shuffle this. I bring 5 here. I say now 5 minus 4. Now guys, you can see now I have removed the negative, and still now it remains the solution is 1. So the same case I will do here, guys. I will come and exchange, so that I will write 1 all over, instead of writing v minus 1, I will now write 1 minus v. With that, we have not changed anything, guys. It's just like I have done here, guys, where inside the bracket, because now this is like it is inside the bracket, because this minus is not studying for v or even negative 1, is studying for everything. So if I want to remove the negative, I just put now 5 as plus and 4 as negative, which is here, and the solution brings us 1, even as it was formerly. And so guys, that's what I have done here. So this one now gives us ln to bracket cx raised to a half, and then close the bracket. I can now come and replace my figures here. 1 all over 1 minus, instead of v, I write y over x, like that. Just as we had formerly. We have formerly replaced y over x with v. And so, up to that point, guys, maybe I can deal with this one first. This one will be 1. I can now write this one 1 minus 1, I put it under x. And if I put it under x, then it will change and be x minus y all over x, like that. This is the same as that. And so guys, finally, I can write it as this. X, I can bring it up here, and then x minus y, like that. And so guys, that's what now I'm going to use here. So we shall have x all over x minus y. This one now gives me natural log of, open the bracket, c x raised to a half, close the bracket, like that. So guys, this is supposed to be our solution, but we can still find the subject of the formula. That is, we make y the subject of the formula. So we do that by finding the reciprocal of that, which is now x minus y all over x. And this other side we do the same, 1 all over natural log of c x raised to a half, like that. So that now guys, I can come and multiply this side with x. I can come and multiply this and multiply like this. I'll put x here. This is x, I bring it here. Then our ln is there. Then c x raised to a half, close the bracket. This other side we have x minus y. So now I want to leave y alone this side. For me, I can bring y this side, and this, the whole of this I bring it this side. So it shall be like this now. It shall be x minus, because this one is positive, it shall now be minus x all over ln c x raised to a half. This one now gives us y. So that is our solution, guys. So here comes our solution finally. So guys, thank you for listening to me.